Okay, here I am. I'm solving Reddit physics problems, and I briefly looked at this to see that it is a legit problem. Uh, I'm just going to solve this problem. It's kind of hard to see, uh, and let's just see where it goes. Should I make it bigger? You can read it. So let me read it to you. I can barely read it. Okay, I do have to make it bigger. Let's see. No, that didn't do it. It's a bad picture. Okay. A man pushes a crate with a mass of 70 kilograms, horizontal floor, constant force in the easterly direction. That's dumb, but whatever. Starting from rest, the trunk reaches a velocity of 1.5 meters per second east, yes. After 3 seconds, the coefficient of kinetic friction between the crate and the floor is 0.34. Determine the man's horizontal floor force. Be sure to apply to draw a free body diagram and indicate the positive direction. No, not positive, east. See? Okay, so let's switch over to paper and let's just solve this problem. Oh, I'm sorry, there's my thing. Okay, so I'm going to start off with a diagram. I'm going to start with the free body diagram. So there's my crate. Now, since we do not care about the rotation of this, we can treat the crate as a point mass. And so I can draw all the forces acting on a point right there. So I know I have the downward gravitational force. I'll write that as mg. I also have the upwards normal force. And that's the force between the surface and the box that's perpendicular to the surface. That's why it's called normal. And then I have this force right here. I'll call that Fp. And then I have this force right there. I'll call that F friction. And I'm going to say positive, which is actually, you need to do this. You should do X, Y. Okay, so let's just start with what we're given. I'm going to write down all the things. I know the mass is 70. I know the gravitational field G, the magnitude, is 9.8 newtons per kilogram. Start from rest, so V0 equals 0 meters per second. V final is going to be equal to 1.5 meters per second. Delta T, the time it takes, is 3 seconds. And we want to find, and mu K is 0.34. That's a kinetic friction. So if I have kinetic friction, if the block is sliding with respect to that surface right there, then I know that I have the following model for the for the frictional force. The magnitude of the frictional force is going to be equal to the coefficient of kinetic friction times the normal force. This is just our friction model. Now be very careful. If it's static friction, this is technically less than or equal to. And this is not. The vector force is just a magnitude because the normal force is up and the friction force is back. So you got to look at the diagram to find that out. Okay, so let's go ahead and write down Newton's second law. So that says that the net force on the object is mass times acceleration. Now, that's a vector equation, so it actually is a little bit simpler to write this as two scalar equations. I can write this as the net force in the x direction is mass times acceleration in the x, and the net force in the y is mass times acceleration in the y. Now, since I have my x-axis that way, and my block doesn't move this way, it stays at rest in the y direction. So that means it has a vertical acceleration of 0. So I have in the x direction, F net x. What forces are in the x direction? Well, I have this push force. I'm just going to call it Fp minus the friction force. Why is it minus? This is in the positive x direction. This is in the negative x direction. So once we switch to x components, I have to include the sign of their components. And that's going to equal mass times acceleration in the x direction, which we do not know. Okay. Now let's do the y direction. F net y is going to be equal to, I have the normal force pushing up, N. I have the gravitational force pulling down, mg. And that's going to be equal to 0 because it's not accelerating in the y direction. So right here, let's go ahead and solve this for the normal force. Why? Because we need that right here. So if I do that, I can add mg to both sides, and I get N equals mg. Now be very careful. in this case, the normal force is equal to mg. That is not always the case. So if I use that over here, I get the friction force, F friction, the magnitude, it's going to be mu k times N, which is mg. So now I know that force, I know the mass. I'm looking for this force, Fp, right? Yep. But I need to find Ax. So if I say Ax is the change in the x velocity with respect to time, I can do that, right? And I know the x velocity. It starts at 0, final of 1.5. So this is going to be the change in velocity is 1.5 minus 0 over the change in time of 3. So I have that. That's 1.5 divided by 3 is 0.5? 0.5, right? Meters per second squared. Let me get... Sometimes I just kind of question myself and I feel pretty dumb, and that's fine. So 1.5 divided by, clear, 1.5 divided by 3. Yeah, 0.5. So that's 5 times 10 to the negative 1. Okay, I was right. So now I know A. I want to find Fp. So let's just solve this for Fp and substitute in this value. So I get Fp equals Max, which I know, plus Ff. So it's going to be Max plus mu k mg. So that's going to be equal to 70. I can factor that out. Times A, which is 0.5, plus 0.34 times 9.8. So let's put that in our handy calculator. So I'm going to say 70 times parentheses 0.5 plus 0.34 times 9.8 close parenthesis equals. And what's that? 268 newtons. The end. I mean, that's kind of a plain problem. It didn't really inspire me to get excited, but maybe it helps. Okay, maybe it's helpful for you. So I'm solving some Reddit problems. I'll put these in a Reddit playlist, link down below, and you can see the other solutions. If you have comments, leave a comment below. I usually answer those.